Okay, hi everyone. Today we're on to chapter 4, which is trigonometry. Okay, and it's going to look slightly different than what you are used to back from grade 10. So, last year, trigonometry involved angles less than 90 degrees. So, if you're given a right angle triangle, missing sides and acute angles could be solved by applying the primary trig ratios, which SOHCAHTOA. So sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. Okay, so if I plug in sine 30 into a calculator, okay, you try it now, okay, you will get 0.5. So this number means that if I have a right angle triangle, doesn't matter how big or how small the triangle is, and one of the acute angles being 30, then the length of the opposite side to that angle divided by the length of the hypotenuse will always be 0.5. Okay, so again, it doesn't matter if it's a triangle that's this big, or if it's a triangle that's this big, or if it's a triangle that's this big. If that angle is 30, then the length of the opposite to this angle, which is across from it, which is right here, divided by the length of the hypotenuse will always be 0.5. Okay? Now, if I type in cos 30, we end up getting this is equal to 0.866, and there's a bunch more decimal places. We'll just keep it like that. Okay, that means that the length of the adjacent divided by the hypotenuse must equal 0.866, which means this would be 8.66. Okay, so that was essentially stuff he did last year. Okay, I'll just do sort of another example of something you might have looked at last year, as you might have had a triangle look like this, like that, and say that that was like 50 degrees. This was x, and that was 10. And you solve for x, you'd have opposite and hypotenuse, so that is your sine ratio. So you'd have sine of 50 degrees is equal to 10 over x. Now, if we type in sine 50, we get 0. We'll just do 3 decimal places, 66. So that means that this side here divided by this side here must be 0.766. So because we have an equation with one unknown, we can now solve for x. What we're going to do is we're going to multiply the x up here. We're going to get x times 0.766 is equal to 10. And then we divide, and we get x is equal to 13.1. Okay, so that was essentially stuff he did last year. This year, we're extending our understanding of sine and cosine. So for example, let's suppose that this angle here was bigger than 90. So let's do like sine of 145. Okay, you get a number. Try a different number. Pick any number you want. Do sine of any number. It doesn't matter how big, how small, positive, negative, it doesn't matter. Let's do negative 45. What do we get? Negative 0.707. So you can figure out the sine and cosine of any angle. It doesn't matter. It's no longer just confined to a right angle triangle. So that's what we're looking at this year. So we have two objectives in today's lesson. One is learning the special triangles, and two is determining exact values for ratios of angles that are multiples of 30 and 45 degrees. Okay, so right here, like 0.866, this goes on forever and ever. And when we're rounding it, we're creating rounding error, okay, which is no good. So we want to create an exact number for this. So when I plug it into my calculator, I will get this number, but it's an exact number, almost like a fraction. All right, so here we go. So first of all, we have our two special triangles. So one's an isosceles and one's an equilateral. So start off with the isosceles. So this is 90, which means this is 45. This is 45 here. That means that this side and this side are the same length. So for now, let's say each one is just a length of 1 unit. That one's 1 unit as well. And then we're going to do the Pythagorean theorem to figure out the hypotenuse. So 1 squared plus 1 squared, okay, is equal to our unknown, which we'll call x squared. So we have 2 is equal to x squared. That means that the square root of 2 is equal to x. So that means that this right here is the square root of 2. Okay, perfect. Now what we can do is actually, okay, let's go to this one here first. Okay, now we have an equilateral triangle, but we're only going to use half of it because that's what we understand. Right angle trigonometry. So we're going to draw a line going down. It's 90 there, which means that's 30 degrees there. Okay, and I'm going to say this one here is 2. So if that's 2, that means that this half here is just 1. And again, Pythagorean theorem is going to give this equal to the square root of 3. All right, nice. Now, what we have is we have 2 right angle triangles. Okay, we have this one here and we have this one here. Just ignore this second part now. We don't need that anymore. Okay, now what we can do here to be consistent, see how this one has a hypotenuse of root 2 and this one has a hypotenuse of 2. Let's shrink the triangles down. Let's shrink them both down so that the hypotenuse is equal to 1. So what we're going to do is we're going to scale this triangle down. So we're going to divide every side by root 2. Okay, so we're going to divide this side by root 2. Okay, so that's going to make it equal to 1. And we're going to divide this side by root 2. And we're going to divide this side here by root 2. Okay, and then same thing here. We're going to scale this one down. So we're going to divide this by 2, which equals 1. And then we're going to divide this by 2 and divide this by 2 here. Okay, now what we've created is some exact values. So let's look here. So we have now that the cosine of 45 degrees is equal to the adjacent, which is this, divided by the hypotenuse, which is this. And when you divide by 1, you don't even have to put it. So that means that the cosine of 45 is just 1 over root 2. And then the sine of 45 is opposite over hypotenuse, which is also 1 over root 2. And then the tan of 45 is equal to the opposite divided by the adjacent. And because they're the same number and you divide them, it's going to equal 1. So we just figured out exact values. So watch this now, right? Type in cos 45 into your calculator, cos 45, and you get 0.707. It keeps going on and on. Now let's type in 1 over root 2. And we should get the same thing. 1 divided by root 2 is equal to 0.707. Awesome. So now, if you're ever asked to determine the cosine of 45 degrees, this is what your answer would be. You wouldn't round it, right? Because rounding creates rounding error. Now, this triangle here, same thing, but now we have the 30 and the 60 we're going to work with. So we're going to have we'll do for each one. So we're going to have the cosine of 60, and that's equal to adjacent over 1, which is just 1 over 2. The sine of 60 is the opposite over that, which is root 3 over 2. And then the tan of 60 is equal to the opposite over the adjacent. So you have root 3 over 2 divided by 1 over 2. You invert and multiply, and you end up getting equal to just root 3. And now we're going to go to the top angle, which is the 30. So we're going to have cos of 30 is equal to adjacent over hypotenuse, which is root 3 over 2. Notice how they just switch. The sine of 30 is equal to 1 over 2. And then the tan of 30 is equal to 1/2. I'll just show you here, divided by root 3 over 2. Invert and multiply, 1/2 times 2 over root 3, and you divide out the 2's and you get 1 over root 3. So this is 1 over the square root of 3. Awesome. So far we created exact values for 45-degree angles, and we created exact values for 60 and exact values for 30. Perfect. Now we're going to extend this to angles greater than 90 degrees, and that'll be sort of our lesson. All right. So now we're going to extend our definition angle is greater by using the unit circle. So the unit circle has a radius of 1, and that's why I sort of did this. I scaled these triangles here. Okay, because now we can use this information to put it in. All right, so this right here is called a terminal arm. And the terminal arm gets rotated counterclockwise. Okay. If it goes clockwise, counterclockwise from positive x axis. Okay, so as you rotate the terminal arm, it stops some point after a certain amount of rotation. So this one here, I said, okay, I'm going to take this terminal arm here, which has a radius of 1, and I'm going to rotate it 30 degrees. Okay, and now what we're going to do here is we're going to create a right angle triangle, just like that. Okay, so now what must the height of the triangle be? What must be the base? So remember that because it's a right angle triangle, we know that the opposite divided by the hypotenuse is the sine, right? So we did it up here already, right? And what do we get? We get the sine of 30 is 1 over 2. So that means that this right here is going to be 1 over 2. Then the cosine of 30 is going to be root 3 over 2. All right. Now, because this distance from here to here is root 3 over 2, and this distance from here to here is 1/2, okay, these just represent the x and y coordinate of this point. Right? All right, beautiful. So notice now, as we rotate this arm, okay, to the left, okay, we rotate it up here, for example. Okay, if we rotate it 90 degrees, right, what's happening to the height of this triangle? The height of the triangle is approaching 1. What's happening to the base of the triangle? Well, the base of the triangle, okay, is approaching 0. So that means that the sine of 90 degrees, remember sine is just the opposite, right? So the sine of 90 degrees is going to equal 1, and the cosine of 90 degrees is going to equal 0. Okay, so just understand that any point on the unit circle now, okay, can be represented as the cosine of the angle and the sine of the angle. So this is your x coordinate, that's your y coordinate. Right? Beautiful. Now, as you pass 90 degrees of rotation, okay, what do you notice about these values? Well, you notice that the x values become negative and the y values still stay positive. All right, good. So let's go on to this angle right here. Okay, so how many degrees of rotation from here to here? Okay, that's going to be 150. Why? Because from here to here is 180, and we're only going to here, so it's minus 30, so it's going to be 150. So this is going to be 150 degrees. All right, so now we're going to have that the cosine of 150 degrees is going to equal, okay, again, it's the same triangle, right? It's the exact same triangle as this one because that's 30 as well, right? And that's 1, and that's 1. So that means that this must be the same as this, and this must be the same as this. The only difference is this is negative. So this is going to be 1 over 2, and this is going to be negative root 3 over 2. So it means that the cosine of 150 degrees is equal to negative root 3 over 2, exact value. And you can try it out in your calculator, plug in cos of 150, get the answer, plug in this, and you'll see that they're the exact same thing. Okay, now the sine of 150 degrees is equal to 1 over 2. All right. Now we're going to go to our next angle. So again, because from here all the way to here is 180, and that's an additional 30, that means that we are now going to have 210 degrees of rotation. Okay? So let's go for 210. So we're going to do the sine of 210 degrees. Okay, again, it's the exact same triangle. right, is these ones, the exact same. The only difference now is because the y value is going to be negative. So this is going to be negative 1/2. And the adjacent is going to be negative as well. So that means that the x and y coordinate of this point, they're both going to be negative, right? So the sine of 210 is going to be, right, again, opposite over 1. So just negative 1/2. And the cosine of 210 is going to be negative √3/2. Okay, good. So that means that the x coordinate, this point right here, is going to be negative √3/2, and the y coordinate is going to be negative 1/2. Okay, so now as you take this terminal, you continue rotating it. So now suppose that we rotate it to 270 degrees, right? If we keep rotating to 270, what do we notice about the height of the triangle? It's going from negative 1/2, it's going down and down, it's going to negative 1. So sine of 270 degrees is going to equal negative 1, and the cosine of 270 degrees is going to equal 0. All right. Now, we're going to look at our last angle here, our last triangle, okay, which is in quadrant 4. So we're going to go like this all the way to there. So that's going to be 330 degrees of rotation, right? Because all the way would be 360, right? Circle's 360, but we stopped 30 short, so we're at 330. So we'll go here. So now we have the cos of 330. Okay, again, it's the same triangle, and the cosine is just the adjacent. So because now we're positive again, it's going to be √3/2. And then we're going to have our sine of 330, which is, and because it's below the axis, it's going to be negative 1/2. Okay, and now to get our tangent, okay, remember our tangent is just the opposite divided by the adjacent, or the tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. Okay, same thing as opposite over adjacent. So that's why I didn't cover tan, just divide them. All right, good. So these are the exact values of multiples of 30 degrees, and let's go to the 45 degree now. Okay. So 45 degree, right? If we go back to what we did earlier for a 45 degree triangle, that means that this is going to be 1/√2, and this is also going to be 1/√2. Okay, now we'll just speed it up a little bit. We're going to go here, here, we'll draw this triangle, we'll draw this triangle here. Okay, and they're the same triangles, so that means that the sides have to be the same. Some are positive, some are negative though. So in this one right here, this is going to be positive, or sorry, √2. And this is going to be negative. Here, this is going to be negative, negative. This one right here is going to be negative, and this is going to be positive. So now we have the cos of 45. This is our quadrant 1. Okay, this is our quadrant 1. So the cos of 45 is 1/√2. The sine of 45 is 1/√2. In quadrant 2, so this is your quadrant 1. In quadrant 2, we're going to have from here to here, which is 135 degrees. So we have cos 135, and we have sine of 135. Okay, and the cos of 135 is going to be the adjacent, which is negative 1/√2. And the sine of 135 is going to be the opposite, which is 1/√2. This is our quadrant 3. This is our quadrant 4. So quadrant 3, our angle is, okay, that's 180, and then another 45, so that's 225. So we're going to have the cos of 225 is equal to, okay, and it's this triangle here, so the cos is the adjacent, so it's going to be negative 1/√2. And the sine of 225 is going to equal negative 1/√2 as well. Okay, and then in quadrant 4, we now have from here all the way to here is going to be 315 degrees. So you have cos of 315 is going to equal the adjacent, which is 1 over root 2, and the, and then the, let's see if I can get back there. Oh, and then the sine, let's see, 1 over root 2, and then the sine of 315 is going to be negative 1 over root 2. All right, perfect. You're going to have to look over that a couple times. This is pretty complicated. Okay, so this example here, I said determine another angle that has the same trig ratio as each angle, and you may include negative angles. So cos 45, okay, so cos 45 is 1 over root 2, so what other quadrant has a positive cos? That's a positive x value. That's quadrant 4, so it's going to be 315. So cos 45 is going to equal cos of 315. And you can check in your calculator by plugging them in. Type in cos 45, type in cos 315, and you'll see that they're the same. So cos of 210, so if we go back here, 210 is in quadrant 3, and it's got a negative, so it's the same in quadrant 2. So now for 210, right, we know that this right here has to be 30. From here to here, so that means that this angle here has to be 30 as well. So it means that our angle that we need to give is rotated from the positive x-axis counterclockwise, so it is going to be 150. Okay, now we're going to do cos of 300. So now I'm going to draw a picture for this one here, okay? So again, 300 degrees, that means that you're going to go here, and we keep rotating 300 degrees, so to about right there. And then just draw a triangle. So that means that this related acute angle here is 60 degrees. Okay. Now, cos is positive in this quadrant right here, right? Because the adjacent is positive. So the other quadrant in which cos is positive is right here. Okay, so that means that this angle here is 60. So that means that cos of 300 is also equal to cos of 60 degrees. Okay, next one, sine of negative 30. So negative angle means instead of going this way, you're going to go down. So that's right over here. That represents negative 30 degrees. Okay, so we don't, that's negative 30 there. Okay, so if you notice that the sine is the opposite, right, over the hypotenuse, and the hypotenuse is 1, so it's just the opposite. So the opposite is negative. Where else is it negative? Over in this quadrant here. Okay, that's where it's negative as well. So that's going to be the same length as that. So the rotation from here all the way to here is going to be 180 plus 30, which is 210. So again, if you type that in and that in, you get the same answer. Sine of 120. Okay, we're going to draw a picture. 120, you rotate, that's 90, so we'll go right there. Which means that the related acute angle, which is the angle to the x-axis, is 60. Okay, and sine is positive. And then which other quadrant is sine positive? In quadrant 1. So that's 60 there. So that means that cos of 120, right, from there to there, is equal to cos or sine of 60. Okay, and then last one, 315. So we're going to go here, rotate 180, 270, keep going to 315. Put in your related acute, which is always to the x-axis. That means that there's 45 degrees left. Okay, and then sine is opposite again, so it's negative, so it's also in this quadrant here. So we draw the exact same triangle here. That's 45 there. So our angle that we have to state though is from here all the way to the terminal arm. So it's going to be 180 plus 45, which is 225 degrees. All right, and that's it for today. Those are your practice questions. Again, you may have to look at the video twice. It's a lot of information. It is pretty complicated. Also, read your book. If any questions, let me know. And I deleted it, but I also have next day's lesson. Okay, in this one here, you're just going to do an investigation and copy out some examples. So you're going to do the investigation. So it's page 243 to 244, numbers 1 to 5. And I want you to copy down examples 1 to 3 on page 244 to 245. And then I want you to try page 246, numbers, let's do 1 to 3 and 5. Okay, that's everything, and this will take you through to next week, because next week is Amnesty Week. Take care.